World is moving towards a more durable, less maintenance products.
Correct.
And that's one of the best parts of the fiberglass composites. It's a fit and forget solution.
They got metal boxes installed, and there was one wire slip, and the entire structure turned into a conductor.
There are actually studies which have shown that a poultry shed made of your fiberglass composites reduce the temperature by 2 to 3 degrees Celsius.
How can we prevent rust in farmlands? Now, thermal expansion is something that's very common. If you see railway tracks, right? Between two railway tracks, there's a gap. That's due to expansion of steel. There would be a little bit of domino effect. First slab collapsing would have led to the second slab collapsing, would have led to the entire thing coming down like that. Farmers look into these FRP profiles for building their cow sheds, for building their goat sheds, for doing any type of poultry farming.
What is the next big thing in construction according to you? What is the most critical thing in construction according to you? What do you feel would be the impact of AI in construction industry on a scale of 0 to 10? So agriculture, one of the largest industries in India, and also the backbone of our country. So what are your thoughts on this? Like, where do you feel fiberglass can play a role in agriculture?
I come from a family of farmers. My grandpa was a farmer, my great grandpa was a farmer, so my uncles were farmers. We still have farmlands. So as a way of giving back to, my ancestors and all that, I did want to do something in that space as well. So now if we were to talk about farmlands and all these spaces, right? You know that chemical fertilizers are used to enhance crop rate or yield rate or whatever, right? When we are designing a structure, we do soil testing. We only check for SBC, which is safe bearing capacity of the soil. We don't look into the chemical composition of the soil. Are there heavy metals? What are the types of salts in the soil? We don't look into any of those aspects. And it's a very common thing that agricultural land has proper irrigation in it as well. Irrigation, chemicals, it leads to a turmoil of hazardous cocktail, right? Now, when this is exposed to a steel structure, what will happen? Rust. How can we prevent rust in farmlands? Now, steel structures are commonly used for border fencing, for cow sheds, for goat sheds, for poultry farming, and so on. In fact, they have some metal roofing as well. Rust is a surface phenomenon. It transmits on the surface. So from bottom up, it will start rusting everywhere. And in fact, even in these, the casing of these underground motors, even they are made up of steel. Now imagine if they were not to rust. We can prevent it by using our FRP profiles. So what I empathize is that farmers look into these FRP profiles for building their cow sheds, for building their goat sheds, for doing any type of poultry farming, for all types of fencing, and even for electric poles, lamp poles and all that, because it's very easy for us to speak about how in the marine region or how in the coastal region or how on hilltops, corrosion is a vital factor. In our own farmlands, corrosion is a very big problem. And our farmers, they are having to, I know my grandpa would replace all these pipes and poles and pillars and piers and whatnot, because constant corrosion. He did not have the knowledge. He thought, okay, steel is the only thing that I have. So it's very important to educate farmers that having FRP, GFRP in your farmland to build all these structures will do a lot of cost saving for you.
100% agree with you, and I think it is a major issue there. And I'm thinking about, let's say, around 20 years back when the PVC pipes kind of came in. Like, people used to kind of ridicule those pipes,
Correct.
saying that what is this? This is, I can break it with my hand. If I just put fire on it, something will kind of happen.
Correct.
And today we have all seen like the biggest
PVC revolution.
PVC revolution. Like, in fact, the biggest consumption of PVC pipes is in the agri segment. But of course, the one challenge with PVC pipes is the strength is not there. And because the strength is not there, people are forced to use steel. But I think by using your like FGC profiles in farmlands, what will happen is that all those points that you said, like say in goat sheds, cow sheds, etc., you will, like in poultry, for example, the bird droppings will fall, ammonia will be there, rusting will happen.
Very acidic, yeah.
It is acidic, and even like some research that we had done was that when the steel rusts, the rust particles can even go into the air and they can get consumed by the animals, and that in turn kind of comes into our food on the table.
Correct.
So those were some points. One is, of course, from the health point of view. There were other benefits. From example, if you take in a poultry shed, there are actually studies which have shown that a poultry shed made of your fiberglass composites reduce the temperature by 2 to 3 degrees Celsius. Now, for every 2 to 3 degrees Celsius which is reduced, the weight of the bird increases by 0.5 kg. Which is the biggest thing in poultry. So I think the possibilities of this material is endless. Just like how the PVC revolution kind of came about 20 years back, I think this is just the beginning of the usage of this. And in general, what we have seen is that the whole world is moving towards a more durable, less maintenance products. Correct. And that's one of the best parts of the fiberglass composites. It's a fit and forget solution. Like, once you kind of install it, it's so easy to kind of clean, even if something kind of
very
happens
minimal
to it.
maintenance.
Very minimal maintenance.
You don't have to keep repainting it.
Exactly.
You don't have to keep checking it for corrosion. You don't have to worry about it conducting electricity.
Yeah.
One more thing I would like to talk about here is, there was this one structure, and I mean, in rural side, I'm talking about tier 2, tier 3 cities. So there was this one steel structure. In that structure, of course, first of all, it's very difficult to find technical labor in these cities. So in that structure, the electrical work that was done was very poor. They got a local electrician to install metal boxes, and not PVC boxes, not FRP boxes, the junction boxes. They got metal boxes installed. And there was one wire slip, and the entire structure turned into a conductor. Anywhere you would touch, it would jolt you. Now imagine a small kid. I can take a jolt, you can take a jolt. Imagine a small kid. If a mother carrying a small child would come in contact with that, it would have been very, very, very hazardous. So educating people about where what product should be used. Had they used, it's as simple as replacing that metal junction box with a PVC junction box or a FRP junction box. As simple as that. And the cost is more or less here and there, right? It's just that having unskilled labor doing technical work, you need to be super cautious about. One more example, there's this building in Sarjapur. Again, same. They go to a random fabricator. In India, we have this one mentality wherein whoever gives the lower quote gets the project. So, a good friend of mine who's an architect, he had actually designed this building. And the structural part of things was done by the fabricator, not by an engineer. And even the execution and the construction was done by the same fabricator. He just told that, sir, 300 mm profile is enough here, 600 mm profile is enough here, we'll just go with it. The entire slab sagged by 1.5 foot. There was a dent in the slab.
My God.
And this was no normal building. This was supposed to be a pub. And on the sagging slab was supposed to be a dance floor. You can imagine, what if there were 10 people, 20 people dancing, especially when they're drunk? Not 10, 20 people. That thing was designed, it was a good 800 square feet space of dance floor. So it could easily accommodate about 30, 40 people at least. Easily accommodate. Huh? What if 40 people were dancing on that floor and the slab had collapsed? And this slab was on the second floor. There would be a little bit of domino effect. First slab collapsing would have led to the second slab collapsing, would have led to the entire thing coming down like that. Because the lower floor cannot take that much of load at once. Point load, UDL, whatever, it cannot take that much of load at once. An entire slab coming down on another slab. So technical knowledge, technical awareness, people should really look into what they are paying for. Are you paying just for the building? Or are you paying for the overall package wherein it's safe for your habituation? Is what has to be looked into. Even when it comes to the type of material being used. I can't simply say, okay, you know what, use this, use that, without analyzing it in a particular software. And we do that. Most people don't even touch base on these softwares. They just use thumb rules and they just say, okay, column has to be this big here, footing has to be this big here, and all that. Let me tell you one thing, Kunal. Over-reinforced structures are more dangerous than under-reinforced structures.
Wow. That's little hard to believe because...
Yeah. I mean, extremely under-reinforced structures are obviously more dangerous. But in the margins, if you're checking, a marginally over-reinforced structure is more dangerous than a marginally under-reinforced structure. Let me rephrase it like that. Because the sheer amount of maintenance issues, the sheer amount of, let's say that there is more load acting on that slab. I literally had this one client, he stays close to my house. So while I was walking one day, I passed by his house and I asked him, I was like, uncle, how come you're, giving such a long span cantilever? Like the column is somewhere there and you're given a 8 feet cantilever and you have a floating column on top of it. He was like, no, my guy, my structural engineer, so on and so forth, said this only. He's a very old guy, very experienced. He told me that he's done this, he's done that and all. I was like, I think you need to recheck into that. Because there's something fishy about this structure. And when he did go back and check, he came back to me, he said, you know what, I've given more steel. I haven't used 8mm and 10mm rods. I've used 12mm and 16mm rods for slab. I was like, that's so unnecessary and that's so unconventional. Who does that? Like, no one's doing that. And the slab thickness is 6 inches. Just because you have dumped steel into it doesn't make the structure strong. Steel is used for a different purpose. When you're putting load, you're putting compression on it. Concrete is good in compression. Steel is good in tension. That's why in RCC, reinforced cement concrete, the reinforcement is steel. Right? Concrete is the hero. Concrete takes the compression strength. Steel just prevents cracks from happening. And
so what happens if more steel is used, out of curiosity?
It can lead to a lot of issues. For example, crack formation is one of those issues. The overall compressive strength of the structure reduces. So let's say you are designing a structure for 10 people to stand. And you have unnecessarily put in more steel reinforcement. If you're building a steel structure, that's completely different. But if you're building a RCC structure and you're just loading it up with steel, then it's not going to have the design capacity to withstand so much load. It's going to bend, it's going to buckle. So that buckling effect is going to be visible, and it can lead to a lot of catastrophes as well. Forget it. Even if it does not buckle, because we don't see a lot of buildings falling down, right? There are some buildings that fail, but we don't see buildings falling down every single day. But if we were to talk about maintenance, maintenance increases. There's surface cracks, there are shear cracks on the surface. Due to that microscopic bending, there are some cracks formed on the surface. Now that cracks can lead to water percolation. Water percolation in RCC member can lead to rusting of the steel. Right. What this does is, it reduces the overall design life of the structure. Let's say I'm building my building so that it lasts for 20 years, 30 years, so that, you know, my next generation also sees, because I do cater to a lot of old people as well. But since you're using, you know, you're under engineering it or over engineering it, or sometimes not even engineering it, because of that, the longevity of the structure also reduces. It cannot withstand so much weight.
I think this kind of compounds in coastal properties, because the corrosion rate is very, very high there. So I think over reinforcement is also an issue, and that kind of brings us back also, that we know that in fiberglass composite, because the tensile strength is so high, you can actually do a substitution. Instead of an 8 mm, you can swap with a 6 mm. But whenever we have suggested this thing, like, there's a backlash. It's like you are trying to make our structures weak. So can you please explain it in maybe in a technical way, that is substitution okay to do in the first place?
See, what we do generally when we are designing any structure is that we look into the overall load of things, and then we decide on the thickness of concrete, the thickness of steel, the number of rods, so on and so forth. Let me give you a rough example. So let's say that I'm trying to keep it as generic as possible so that everyone understands. So let's say I'm building a structure for 10 people. Now the load of these 10 people are gonna be distributed in one column. There's one column and there's a flat surface, and there are 10 people on that flat surface, right? So the load of the column is taken, the overall load is taken by that one column. Now the type of reinforcement that I should use should take in the overall load. Now let's say there are softwares, StatPro, ETABS and all that, wherein it gives us the design load. And the number of rods that we need to put in is based on that design load. We experiment. First I add, let's say, I'm just giving you an example. Let's say I had around 12 rods of 10 mm. I see that it's strong. Now 12 rods of 10 mm is very expensive for me. I want to substitute it. What do? I use 8 rods of 12 mm. It still stays strong. Now I'm saving on material, because 12 rods of 10 mm will be more costlier than 8 rods of 12 mm. Right? Or vice versa, whichever is more expensive. Now what as an engineer I would do is, if 12 mm rods are cheaper, I'll go for the 12 mm rods. If the 10 mm rods are cheaper, I wouldn't say cheaper, efficient, cost efficient, I would go for the 10 mm rods. Similarly, in GFRP, since the tensile strength is so high, where 10 mm has to be used, we will use 10 mm. But where 10 mm is not necessary and 8 mm can be replaced, we should use 8 mm. When we are comparing this with steel, right, obviously the tensile strength is more. So using a lesser dimension rebar makes absolute sense in terms of design perspective, because we take the overall load. Yeah.
Yeah, I think that kind of answers it, that literally, if you put from a design perspective, like, you can do easily you can do a substitution. So definitely, like, there are solutions which are out there, where, because again, it's come back to the same point that this is not a new material. It's been around for a while.
Ages. It's been there for ages.
It's been used very widely, and there are structures which are standing for 20 years, 30 years, 40 years. Nothing has really kind of happened to it. If there was some issue where it would not bond with the cement or something, those structures would not be made in the first place at all. So I think that's something which was very interesting. One more query we get a lot, especially from the structural engineering community, is that the rate of expansion of steel is very similar to that of the rate of expansion of cement. But if you take the GFRP is little different. So what happens?
Correct. I mean, that's a brilliant question to begin with. Steel does expand. Elongation on GFRP is very less. Elongation in GFRP is less than 3%. Whereas in steel, it's between 4 to 25%. Maybe if you're using some other admixture, more carbon into the steel, it might elongate even more. But what I would like to say on this is, there are ways on how you can make the structure wherein the concrete does not expand too much. And even if it does expand, we can provide spacers, we can provide expansion joints, we can take so much care. And this is no new technology. You can check expansion joints in any codal book, right? Steel expands. Steel expands too much. Now, if we were to spin the conversation a bit more, RCC or cement, let's not talk about RCC, let's talk about a cement that's already set. It has lesser elongation than GFRP. Whereas elongation of steel is more. So how can someone accommodate that? Won't it create tension on steel? Because steel wants to expand, concrete is not letting it expand. If it does expand, there'll be cracks on the concrete. So it all boils down to how the material is being engineered, right? In every structure. Coming back to the expansion joint point. Now, thermal expansion is something that's very common. If you see railway tracks, right? Between two railway tracks, there's a gap. That's due to expansion of steel. You have your concrete roads. Have you seen grooves on your concrete roads? The slab being cut. That is done to accommodate steel expanding. Now, if I were to say, don't use steel there, it's bad because it's expanding. Would it work? It wouldn't work because there are already structures that are being made with the ability of steel to expand. Now, can we make structures with the ability of GFRP to not expand? Yes, we definitely can. Because end of the day, if you do look at it, expansion voluminous in concrete, right? It's not pulling the entire member. The volume is increasing, right? At the same time, it is not too much. And that bare minimum expansion, GFRP can easily accommodate.
Got it. So, like, there's no issues whatsoever, like, if we use it. Great. Thanks.
I wouldn't say there are no issues. I would just say that what material has to be used in a certain manner has to be used in a certain manner.
Got it. So, you need to engineer it accordingly. Got it. So, let's move on to a rapid fire round.
Oh, wow.
So, so I'll be pushing the boundaries a little on some of those questions.
Please do.
A disclaimer to the audience, I've not given the questions to him beforehand. So, we'll have on the spot things with him. So, Dr. Srujan, ready for the rapid fire round?
Of course.
Okay, let's get rolling. What is the next big thing in construction according to you?
New structures, new materials. Material science is definitely booming.
Got it. And this is a controversial one, which constructional professional is the most underrated? And your options are PMC, structural consultant, MEP consultant, architect, civil contractor.
No brainer. I think it's a structural consultant. An average structural consultant makes less than what a labor makes in a site.
Oh, that's really kind of thing. And I think that's where this is a good option for structural consultants to really start embracing FGC because their value can kind of like really go up by studying this material in depth.
Of course. Any new material, they have to be hooked onto it.
What is the most critical thing in construction according to you?
The most critical thing in construction would be the structural design.
Okay. Yeah, that's why structural engineer is very, very important. Next, coming to fiberglass arena, fiberglass rebars, fiberglass profiles, fiberglass mesh. Which do you see has a bigger future?
Profiles.
Okay.
Yeah.
Any top 1 or 2 reasons why you say that?
The market value for profiles is much larger. I think steel is there to stay, and it will take some time for the Indian consumer to change their mind from using steel rebars to using GFRP rebars. But profiles is something that is gonna take over the market soon.
What do you see taking the market share?
Like you said, pergolas, all the fancy
percentage of the industry, what? 10%, 15%, 5%?
I think I have to be a little bit biased here. I think about 20 to 25%.
20-25. That's huge. Like we are gunning for a 5% and 25% coming from the expert, I think is like, wow. Okay, now one thing that you love about the Indian construction industry.
Labor availability, they say it's a curse, but I've seen that it's a boon because I've worked in the UK as well. You don't find half as much as labor that you do in India. So manpower.
Awesome. One thing you hate about the Indian construction industry.
I'm not going to say anything. Unorganized sector. It's a very unorganized sector. I think a lot of non-technical people are trying to do technical things. So that has to be looked into.
Yeah, so a lot of education needs to be there. Okay. Net carbon zero initiatives, here to stay or just a fad?
They're definitely here to stay.
Awesome. And again, this is completely out of the thing. One out of the box idea for traffic problems in India.
Oh, fixing the potholes to start with.
Potholes. Actually, we have a startup called Pothole Raja that does this. He's a good friend of ours. Great. Okay, now moving to a little bit to the tech side, what do you feel would be the impact of AI in construction industry on a scale of 0 to 10?
Massive. I think it's going to cut down a lot of technical people. Whatever 10 people could do, one person with AI support will be easy to achieve the same thing.
Wow. So what are the top 2-3 areas where you're seeing it would impact first?
Digital design, definitely. Technical design again. And I see a lot of, 3D printed houses. That's also booming. L&T did their first project in Bangalore. So I see a lot of, technology revolving around that aspect of things.
Awesome. Something nobody is noticing or noticing very little, but according to it's going to become huge in the future.
GFRP.
Thank you for that. Okay. Finally, coming back to the the fibers, which is your favorite basalt, glass, aramid, carbon?
As biased as I would like to sound here, but CFRP steals the show because that's a whole different level. That's like rocket science, right?
Yeah.
So CFRP.
Yeah, I agree on that aspect. I've seen carbon fibers is amazing. Like
it sure is.
It's a super material. Hopefully, we can introduce that soon in India. Awesome. So that was pretty much from my side for the rapid fire round. So thank you so much.
Thank you for having me. It was a wonderful conversation. Yeah. And I hope our material grows and captures a very big market.
Absolutely. With your well wishes and support, I'm sure we will rock the Indian industry. So thank you all for tuning into this particular podcast. I hope it was very informational for you. We covered a wide range of topics, right from where can fiberglass composite be used, what is the future of fiberglass composite, what are the commonly asked questions, how does it bond with cement, how can the fixing be done. And we heard it from the horse's mouth, Dr. Srujan, who's devoted 6 years of his life in the research of fiberglass composite. So really blessed to have such a knowledgeable person on our show. So stay tuned on the channel. We will be coming up with a lot more interesting insights for you so that you can take the right decision with regards to what is the right material for your construction project. Thank you once again for tuning in to the Shine Star channel. Thank you.